Hello everybody. This set of notes is going to cover 5.5 sine and cosine ratios. The last set of notes that we had, we talked about tangent ratios, and so we're going to finish off with sine and cosine today. As a reminder, these are the three ratios that we are able to use when we are given angles in a right triangle other than 45, 45, 90, and 30, 60, 90. It represents sine, and the ratio is going to be the opposite over the hypotenuse. This is going to represent cosine, which is the adjacent angle over the hypotenuse. And then t is tangent, which is the opposite side over the adjacent side. This is the one that we talked about yesterday, or the last set of notes, whenever that was, okay? So today we're going to do kind of a mix of all three. All right, so when we look at this first example here, remember that I am looking at this angle. We've got 70. The side of cross will always be the opposite. The side next to will always be adjacent, and this one will always be the hypotenuse. So when you have a problem like this, you have to decide what variable you want to solve for first. I typically solve for x first. So right now, what I have, if I'm looking for x, is I have the opposite, and then I need a side with a value, which for us will be the hypotenuse. So because I have opposite and hypotenuse, when you look up here, out of all of your ratios, sine is the one that requires the opposite side over the hypotenuse. So I'm going to set this up by doing sine of 70 is going to equal the opposite side over the hypotenuse. As a reminder, I have to multiply both sides by whatever is in the denominator in order to get x by itself. And then I need to pull up my calculator. Remind me later. I'm going to pull up my calculator. I'm going to scoot it over just a bit. Leave me alone. Okay, I'm going to make sure that degrees are turned on. So as a reminder, if you don't remember if your degrees are turned on, you need to go to mode in your calculator and make sure that it says degree and not radian. I want degree. Okay. Now I'm going to type in 25, and then instead of tangent, I'm going to hit sine of 70. And I get 23.49. So I think this wants us to round to the nearest tenth. Yes, it does. So x will be 23.5. Now, if I'm looking at y is going to be my adjacent and my hypotenuse. And if you look back up at your options, adjacent and hypotenuse are going to come from our cosine ratio. So I've got the cosine of 70 is going to equal my adjacent over my hypotenuse. Multiply both sides by the denominator, and you will get 25 cosine of 70 equals y. So 25 cosine of 70, and that's going to give me 8.6. And that's how we use sine and cosine ratios. Moving over here to the second example, here's my angle. This is my opposite. This is my adjacent, and this is my hypotenuse. I'm going to solve for x first. X has my hypotenuse, and then I need the given side, and the given side is way over here. That's going to be opposite, so I need opposite and hypotenuse, which is going to be sine. So I've got sine of 65 is going to equal my opposite over my hypotenuse. This one gets weird because remember that we have to multiply both sides by x first, and then we will go back and divide by sine of 65. So all in all, I will have x is equal to 15 divided by the sine of 65. 15 divided by the sine of 65. And I get that x is 16.6. And then now that I'm looking at y, I need y, and then I still need that given side. So that's going to be opposite and adjacent. So this one's going to be fun. I get to go back and do tangent again. So the tangent of 65 equals opposite over adjacent. Really all that's happening is my y and my tangent are going to switch places. So I have 15 divided by the tangent of 65, and that's going to equal 7.0. And yes, you do need the 0.0. Okay, so on numbers 3 and 4, I am looking for my angle. Get away from me. I am looking for my angle. If you don't stop, I'm going to lose it. Okay. And I have the adjacent side, and I have the hypotenuse. So that's going to mean that I'm going to be using cosine. So cosine of x is adjacent over hypotenuse. And remember, when you are looking for an angle, we need to do the inverse. So we're going to do cosine inverse this time. This will be 8 over 20, and that's going to equal x. So second cosine of 8 over 20 will get me 66.4 degrees. Please don't forget your degree symbol. Over here, I've got my angle. This is the opposite, and this is the hypotenuse, which means that I'm going to be using sine this time. Opposite over hypotenuse, we have to do sine inverse. That's going to be 15 over 40, and that's going to equal x. So second sine of 15 over 40, and that's going to equal 22.0 degrees. Okay, I am going to go ahead and skip numbers 5, 6, and 7 because it's just the same thing over and over and over again. I'm also going to skip number 8 because, again, same thing over and over and over again. But I am going to look at numbers 9 and 10. When I look at number 9, I'm supposed to be looking for the measure of angle A. When you... Oh my God, sorry, I just like threw my Apple Pencil. Okay, so I'm looking for this angle, so I'm gonna go ahead and mark that as an X. Remember that we cannot use trig unless we have a right triangle. So what I'm going to need to do is I'm gonna need to split my triangle down the middle. Remember that this is an altitude. And one thing about altitudes is when you drop them, they create a perpendicular line with the base of your triangle, which means that you're going to get right angles. Now, the thing that I have to notice here is that I actually have an isosceles triangle. And when you have an isosceles triangle and you drop an altitude from the vertex angle to the base, this 76 can actually be broken into two congruent sides. So an altitude is going to end up making this split evenly down here. And now that I have that, I can just use this right triangle over here to find the measure of angle A. So I have the adjacent side and the hypotenuse, so I know that I'm going to be able to use cosine. So cosine of x is equal to 38 over 48. Because I'm looking for my angle, I have to do cosine inverse. So we've got second cosine of 38 over 48. And that's going to equal 37.7 degrees, okay? If we don't have a right triangle, we need to make a right triangle. Lastly, I was given that angle PSQ, so this angle here is going to be congruent to angle SRQ, this angle way over here. Okay, so angle W and that top angle are going to be the same thing. It says I need to find the measure of side X, the measure of side Y, and I also need to find the measure of angle W. So I'm going to actually focus on this side first. Okay, and I've got a right triangle, so I know that I can find angle W by doing, I've got opposite and hypotenuse, so I can actually do the sine of angle W, and that's going to equal 12 over 17. I can do sine inverse of 12 over 17. So, whoops, not that. Get out of there. So second sine 12 over 17. And I get that angle W is essentially 45.0 degrees. Now, in reality, angle W is 44.9, blah, 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 blah. Okay? So I have to keep that in mind when I plug that in up here, okay? Because I need to ensure that I'm using the whole entire angle so that I'm not rounding and then rounding again, okay? So now what I'm gonna do is I'm gonna look at this triangle over here, and I'm gonna first solve for x. So when we look here at this triangle, X is my hypotenuse and 12 is actually my adjacent side, and then Y is my opposite side. So I'm going to start by doing, I'm going to find X first. So I have to use adjacent and hypotenuse, so that's cosine. So the cosine of my star, which is angle W, is going to equal 12 over X. So x will equal 12 divided by the cosine of that top angle. So when I plug this in, I'm going to do 12 divided by the cosine, and then I'm going to scroll up in my calculator and highlight 44.9 and then hit enter so that it puts it into the parentheses. And now I can get that the measure of side x is 16.9. Now I need to go and find side y, and that is opposite and adjacent, so I get to use tangent. So tangent of that funky angle will equal y over 12, opposite over adjacent. Wait, opposite over adjacent, yeah, okay, so 12 tangent of that big decimal. So 12 tangent of that big decimal, and I get 12.0. And that is how you will work a triangle like that, okay? If you have any other questions, please go see your teacher during their normally scheduled tutorial times. The 4 questions that I skipped will be in the completed notes for you if you need them. But that is all I have for you, and I will see you in the next video. Bye-bye.